One of the most useful components in a lot of electronics projects, especially Arduino projects where you want to have some kind of interaction with what you've built, is a push-button switch. A push-button switch is a little bit different from, say, a wall switch, in that, unlike the wall switch, it doesn't stay in the position you leave it in. The switch that controls my lights, for example, when I turn it on, it stays on until I flick it off. A push-button switch only makes a connection when the button has been pressed. And to show you what that looks like, I've rigged up a very simple circuit here using a 9-volt battery, an LED, a resistor, and a push-button switch. And when I press the button, the light turns on. When I release the button, the light goes off. So there's only a connection going as long as I'm holding that button down. And you'll notice, unlike all of the components we've used in previous projects, the push-button switch actually spans this gap where nothing is connected. Internally, it's actually designed to make use of that. If you look at the pins on the screen here, I've got terminal 1A, terminal 2A, terminal 1B, and terminal 2B. Inside this switch, it's wired up so that 1A and 1B are always connected, and 2B and 2A are always connected, but the rest of the connection from 1A to 2A only happens when I press the button. In this very simple circuit, as you can see, the light is only going on when I press the button. We can use this component to control various things within the Arduino. We are eventually going to work towards adding a button into the chaser that we built in the last session, but before we do that, let's build a very simple project using this button and an LED. I'm going to modify this design that I've got here in front of you, and we're going to hook an Arduino up to it. So, let's delete our power source. We don't need that. Let's drag in an Arduino for something we're going to use. And again, I have a red LED and a push button, and as usual, a 220 ohm resistor. So let's do like we've done before and rig up this LED directly plugged into our Arduino. I'm going to use pin 8 for the LED. You can use whatever pin you want. 8 just happens to line up with where I put the Arduino. I'm also going to connect the ground, or the negative, into the ground of the Arduino. And do that, as usual, with a black wire. Now this push button, I'm going to rig up somewhat differently from that very simple setup you saw before. And I'm going to move it over to the side because we need to add some other components to this. Just like an LED, which in every Arduino project always has to have a resistor in it to stop it from blowing, we use resistors with push buttons. However, we use them for a very different reason. We want, because as you know, we're working with digital signals here, we want to make sure that the current flowing through our button is either going to be a 1, so there is current, or a 0, there is no current. Sometimes with these buttons, when they're not connected, there is still a little bit of current flowing through them. We can stop that completely by using a very powerful resistor. So I'm going to drop a resistor here. We're typically working with the LEDs with the 220 ohm resistor. For our purposes, we're going to use a 10 kilo ohm or 10 KO resistor, several times more powerful. We're also going to rotate this to get it out of our way. So if you click up here in the top left, you'll see that I can rotate any component. I'll just keep going around so that you can see this. I can rotate any component to the right by, I think it's 40 degrees. And I'm going to hook that resistor up to one of the terminals, in this case terminal 2A. I'm going to hook terminal 1A directly to the negative and make that a black wire. And I'm going to draw some power for this from the Arduino. I'm going to take it out of the 5-volt connector down here at the bottom. And I'm going to bring that all the way up to the resistor. And make this, you know what, I'm going to leave this green just so it stands out as different. So this will be a green wire. I'm also going to connect to the Arduino. I need an input of some kind. So anywhere along this connector here, I'm going to draw a wire, and I'm going to bring it into pin 3. Let me put a bend in there so that it looks a little bit better, and another one here. So wiring-wise, I have this 10 kilo ohm resistor, this very powerful resistor, going from the positive side to pin 2A. From the same row, somewhere in that connection, I'm going into pin 3, and the negative from the push button switch, or rather terminal 1A, I'm calling the negative, which I'm plugging into the negative power rail. If I run this, unsurprisingly nothing happens. We haven't written any code to work with this. So now let's jump into the code. As usual, by default, it wants us to be in this blocks thing. We're not going to use blocks. We're going to go into text. Yes, I'm sure we want to do this. And we don't need most of this code, so we can actually delete this part. We're going to want to declare some universal variables here. Just like we've done before, I'm going to define an integer, a whole number, which is going to be my LED pin. And my LED pin here is pin 8. I'm also going to declare my button pin. Now my button pin here is pin 3. My LED pin, I'm going to change this to be output. So my LED pin is an output pin. And now for the first time in this series, we're going to introduce input pins. So my button pin is going to be an input pin. I have my 2 pins declared, my output and my input. We are going to introduce, in this session, something that we haven't covered before. In the last session, we've looked at loops and how to loop through code. This time we're going to do something called a conditional. Now, a conditional is checking to see if a condition has been met. In plain English, if this happens, then do this. In code, in C like we use in Arduino and in many code languages, we write a conditional by using the word if. We want to define our condition, and we'll do that in round brackets. So if something, and then curly brackets for what we want it to do. If this condition, do whatever's in these brackets. Now we need to get something, some condition we're going to check here. And what we want to check is to see whether or not the button has been pressed. Now, we can't just say button has been pressed, it won't know what that means. We need to write that in a coding function. And to do that, we're going to create a new variable to hold the value of the button. I'm going to declare that right up here in my global variables. I'm going to declare something called button, 2 T's, button read. I don't know its value yet, so I'm just going to put a semicolon in. You don't have to give a value when you declare a variable. So int button read, this button read will hold the value of whether or not the button has been pressed. And we're going to assign that right now. So button read is equal to the opposite of a write is a read. We want to get the value from this button. So digital read button pin. So its value, semicolon at the end of the line, its value will be equal to the value of that button. Now button read, it's a digital read, it can have one of 2 values, a high or a low, a 1 or a 0. This is going to seem somewhat counterintuitive, but with a push button, when the button is not pressed, the value is high. When the button is pressed, the value is low. You could think of this in almost physical terms. When it's not pressed, it's up. When it is pressed, it's down. High is up, low is down. The reasons for that are more complicated than I have time to get into, but it has to do with this resistor we've plugged in. This is something called a pull-up resistor. And if you want to know more about how those work, there is a lot of documentation online about pull-up resistors, but we're not going to cover that in this session. So we have 2 possible states. It can be high or it can be low. If the button read is high, and the way we write that in this particular coding languages and many other languages is using 2 equal signs. You can think of it as being is equal to. So button pin equals, only one of them, is equal, you have two equal signs. So if button read is equal to low, if the button has been pressed, we're going to turn the light on. So digital write, LED pin, high. So now if we run our code, when we start this off, nothing happens. When we press the button, the light goes on. You may find that you have to press the button more than once. It doesn't always get it right. That is an unfortunate glitch of this simulator. With a real project, you'd probably see it happen right away. So when we press the button, the light goes on. It never goes off again, because we haven't told it when to turn it off. There's a couple of ways we can do that. We could simply say, if the button is not pressed, so if button read is equal to high, we'll write the curly brackets for our conditional. So if button read is high, we're going to turn that light off. So digital write, I can just copy it from right here. Digital write, LED pin low. And now if I run this, when the button's pressed, the light is on. As soon as I let go, the light goes off. But doing something like this doesn't actually make use of the Arduino. This is exactly the same thing that was happening in the very first circuit I built, which just had a battery in it. If we want to make some smart calculations happen here, we're going to do something a little bit different. So instead of just telling it to go off, I'm going to delete this code. We're going to work with something we already know. I'm going to set a delay, let's say a half second, 500 milliseconds, after which time I'm going to turn the light off. So digital write LED pin, and instead of high, it's going to be low. So now when I press the button, the light goes on for half a second and then turns off. Now we're starting to use the Arduino as a controller, not just a power source. So we've, using some very basic components, created a system where we can control what a light does by pressing a button. We're going to make this even better. So what we're going to set this up for is that when we press the button once, the light goes on. When we press the button again, the light goes off. That's called a toggle. So a toggle switch is either on or off, kind of like a light switch, except that we're doing it with a button. We're going to have to introduce some new concepts in order to make this work. One of the first things we have to look at is a new kind of variable. We've only worked so far with integers. Integers, if you don't remember, are whole numbers. So that is 0 to, I think it's 25,000, all the way down to minus 25,000. The range changes from language to language, but that range of whole numbers essentially allows a huge number of possibilities. We're going to introduce a new kind of variable now called a Boolean. And a Boolean as a variable, Boolean is spelled like this, B-O-O-L-E-A-N. A Boolean can only have one of two values. It can only be true or false. It can only be 1 or 0. Very much like our digital outputs. It can only be on or off, high or low, 1 or 0, true or false. For us, that's really useful because we can flip that variable back and forth from 1 to 0, from high to low. We're going to call this Boolean toggle. And we don't know its value, so just like button read, we're just going to end it with a semicolon. You may notice that Boolean didn't turn purple the way most variable types go. That's not a problem, it just doesn't do it in this particular code editor. So we've declared a Boolean toggle up here at the top. We can use this toggle to switch the value of the light from on to off. So this code that we've built here, which I'm going to comment out because you may want to refer to it later, I'm going to use a multi-line comment, which is /*, then underneath */. I'm going to save this for later, just because I don't like to delete code if we don't need to. So our button read, this is going to stay the same. Our button read, we are reading the value of the button. However, we are going to use button read to toggle our switch. So, as we know before, a conditional structure, if round brackets button read is equal to, two equal signs, very important, low. If the button has been pressed, this should look very similar to what we did before. So if the button has been pressed, here, instead of turning the light on, we're going to change the value of our toggle. So toggle is equal to toggle equals 1 equal sign. And this is a fantastic shorthand in code. Exclamation mark means not, or the opposite of toggle. So what this line means is whatever the value of toggle is, make it the opposite. If it was 1, make it 0. If it was 0, make it 1. The reason we can do this is that we've declared a Boolean variable. This can only have one of two values. So if the button has been pressed, change toggle to be its opposite. And now that we've made this toggle, we can use this flipping state to do something with our light, to turn it on or to turn it off again. We do that by writing a new conditional. If toggle is equal to two equal signs, 1, we're going to do something. And in this case, if toggle is equal to 1, we're going to turn the light on. I'm just going to copy it out of this commented code, turn the light on. If toggle is equal to 0, we're going to turn the light off. So I'm just going to copy this out of here and make sure we have a semicolon after all of those lines. Now if I run this code, when I press the button, the first time the light goes on, when I press it again, the light goes off. Now you'll notice that it's flickering. And the reason it's doing that is that this is checking many, many times per second. So we're going to slow this checking process down so we don't catch it sort of halfway between. We can do that very easily by just adding a delay. In this case, we're going to put a pretty short one in. I'm going to put a delay of 100 milliseconds. So this putting in this delay here should stop that flickering or it reading the button being pressed more than once. Now when I press the button once, it goes on. When I press it again, it turns off. On, off. So we've created a very simple, electronically and relatively simple code-wise, toggle button on and off. And again, sometimes you might have to press this more than once if it's not working. That is a glitch, again, of the simulator, not so much of the code. This very simple structure of a push button to toggle something with this very high value resistor can be applied to all kinds of purposes. We're now going to take what we've done here and add it into the chaser we built last week. So if we come back to Tinkercad, if we find our chaser, now this is what I called mine, chaser September 24th, we're going to make a duplicate of it. I'm going to press here on the gear button and duplicate. By the way, if you don't have a copy of the chaser from the last session, in the comments for this video, I'm going to post a link to my public profile on Tinkercad where you can go find one that I made and then copy that and work on your own so that you don't necessarily have to build this chaser from scratch. This will save us a lot of time. I'm going to rename this toggling chaser. You can call it anything you want as long as it's something you'll remember. And I'm going to add a push button into this circuit. So the push button, just like last time, I'm going to connect terminal 1A into the negative, and I'm going to connect 2A through a very high value resistor. You do the same thing and make this a 10 kilo ohm or 10,000 ohm resistor. Rotate this to lie flat. Bring it into my circuit on a terminal 2A. Also on terminal 2A, I'm going to connect using another wire into pin 3. I'm going to leave this green just so it stands out against the red. And finally, the other end of this resistor, I'm going to connect into the 5 volt power on the bottom of my Arduino. So electronically, this is all we have to add. Code-wise, we're going to bring in a lot of the code we wrote from the last project we just did, where we're toggling with a button. We're going to add a lot of that code into here, and we're going to use a lot of the code that already exists. This chaser, as you remember, goes back and forth. It's a sweep chaser left and right, or a scanning chaser. We're going to use the button to control the direction the chaser is moving in. So in order to do that, we need to declare some new variables. I'm going to add an integer to hold my button pin, and add another integer to control my button reading. My button pin is, just like last time, pin 3. My button read, I don't know the value of. I don't need to declare it. I can just put a semicolon. I'm also going to use a Boolean to toggle. So I have a Boolean for toggling. I have an integer for button read and an integer for the button pin. I'm going to add to this code that button pin, or pin 3 in this case, is an input pin. In this case, button pin is an input. And now let's modify this to add some conditionals to it. So we are going to, first of all, get our button read. So button read is equal to, just like before, digital read, get the signal from the button pin. Also, just like before, we're going to, right now, flip our toggle. So, if conditional button read is equal to low, if the button is pressed down, we're going to toggle. This is going to sound confusing. We're going to toggle our toggle variable. Toggle is equal to, just like before, exclamation mark toggle. So not toggle, the opposite of the toggle value. Now we can frame these directions inside a conditional. If toggle is equal to, I made the same mistake up here. Anytime there's a condition, we need 2 equal signs. If toggle is equal to 1, we're going to run this direction, this first direction. I'm going to add closing brackets after that. So I essentially wrapped this for loop from last week into a conditional if toggle is equal to 1. I'm going to write another one here. If toggle 2 equal signs 0, we're going to do the opposite. So now if I run this, it'll start off going only left to right when I hit the button. And again, this time you might have to click it a few times. So when I change the direction, and the reason this is happening is that we haven't put that delay down at the bottom. So I'm going to write in that same delay we did last time, just to afford us some time to press it, a delay of 1/10 of a second. So now when it starts, it goes one way. When I press the button, the direction reverses. Now, if you really wanted to make this work every time you click, you'll notice sometimes I had to click a few times. If you really want to make this work every time you click, if you're patient enough to play with this delay, you can get it down to a value that will essentially read every time you press. For our purposes, I'm okay with this the way it is. However, feel free to play with the delay just to try to get this to be more sensitive if you want it to respond properly. So that sums up all of the components we talked about today. We've added a whole bunch of new concepts that we hadn't seen before. Electronically, we introduced a push button. We talked about the bigger resistor, the pull-up resistor we need to add in there. We looked at new kinds of variables in our code as well. We introduced the Boolean, which is a variable that can be either true or false, 1 or 0, high or low, on or off. It can only have one of those two values. We also introduced conditionals. A conditional is essentially a check to see if something has been met. Is this on or is this off? We will, in future sessions, look at multiple possibilities of conditionals and other ways we can express conditionals. But for now, it's just checking to see if something has been met. For example, if the button has been pressed, if the value of that button is low, if the toggle value has been set to 1 or to 0. And then finally, we looked at using a variable, this toggle variable, to flip something back and forth. So setting a variable, a Boolean variable specifically, to its opposite as a way to flip something back and forth. In this session, for the very first time, we started working with inputs, with some sort of way for the user to interact with the program when it is running. Today we looked at a push button, which allows us to turn something on or off, or change the direction of something. For example, our chaser going left to right and right to left depending on the button press. In the next session, we're going to start working with more intense controls. We're going to add dials so we can affect values. We're going to hopefully get into changing the color of a light using a dial. So we're going to explore a lot more in the user interaction, user control side in the last session. Thank you very much for joining us, and I look forward to seeing you in part 4.